Okay, so once we have balanced the reaction and checked that the law of conservation of mass is working properly by calculating the grams in both sides of the reaction. Remember that to calculate the grams we need the molar masses, and we will multiply the molar masses by the number of moles we have in the reaction. And the number of moles is given by the coefficient in the reaction. Okay?
Yes.
Well, now, what about working with gases? Which are the main data we should know about working with gases? So we know that at STP,
1 mole equals,
and STP means 0 Celsius and 1 atmosphere. And you should also remember that 0 Celsius is 273 Kelvin. And 1 atmosphere can also be expressed, Diego, as 760 millimeters of mercury. Diego. Okay, so at these conditions, at these particular conditions, I am recording the session, so everything you say will be here. So at STP, 1 mole of gas,
I'm going to get out my notebook, all right?
okay, will occupy 22.4 liters. This is the volume of 1 mole of gas at those conditions.
oh yeah.
Any gas. It doesn't matter the gas. So, we already know. What? Okay, if you are at 0 Celsius at 1 atmosphere of pressure, 1 mole of any gas, it doesn't matter if it is oxygen, hydrogen, neon, carbon dioxide, or any gas, will occupy a volume of 22.4 liters. Imagine a balloon with a capacity of 22.4 liters at 0 Celsius, 1 atmosphere. Okay?
¿Esta reacción está en STP o no?
Excuse me?
¿Esta reacción está en STP o no?
We don't know yet. I haven't told you the conditions.
Ah, ¿me vas a decir?
Yes. This reaction may happen at any temperature. And this is what we will need to calculate. Okay?
Entonces el 22 salió de... Sí, o sea, 1 mole of gas es 22.
Okay, 22.4 liters equals 1 mole comes from Avogadro's works. Okay? He was working with gases and volumes, and from what he did, we know this. We already know that 1 mole equals 6.02 times 10 to the 23 molecules, and it also equals the molecular mass of the substance in grams. But here, we will work with the molar volume of gases. It depends on the problem. Okay? Now, if I go to the laws of gases, I will delete all this.
Hay que convertir los grams a moles.
If we work with gases, with laws of gases, you only need to remember 2 formulas. The combined law, no, it is P2. This is one of the important formulas. And remember that if you keep one of the 3 variables constant, you will have either Boyle's law or Charles' law or Gay-Lussac law. Okay? And the other important formula is the one that involves the number of moles. Where P is pressure, then we have volume, the number of moles, the gas constant, and the temperature. And of course here, the gas constant is calculated considering STP conditions.
So 62.4, you know.
62.4 in millimeters of mercury, 0.082 in atmospheres. Okay? You will have the data too, yes.
Con la primera puedes hacer las tres,
The other three formulas, yes. You just keep one of the variables constant, you take it out from the formula, and then you have the other three. From this one, you can have this one, where temperature is constant. We can have this one, where volume is constant.
solo quito la que es constant.
Yes. And you can have this one, where pressure is constant.
Pero siempre hay una constante.
It depends on the data you have on the problem. Okay? Always analyze the data you have on the problem. Okay? Well, so once we have remembered this,
And the pressure, what is going to be?
it depends on the problem. Okay? Everything depends on the problem. So let's make a problem. Okay, let's suppose that we have 3 liters at, yes, let's suppose that we have 3 liters of hydrogen at 25 Celsius and 2 atmospheres. For example, from this data, I could ask you,
Es pressure times volume divided by volume.
how many moles of hydrogen do we have here? No son adivinanzas. You need to do the calculations. So please do it.
El hydrogen tiene 1.
1.68.
¿De qué? Es 1.008.
Okay. What will you do? Which formula will you use here?
Tiene 2. How many moles? Tiene 2.
Okay.
Constant.
So we have, what is 3 liters?
El volume.
Okay, we have a volume here. We have 25 Celsius. What is 25 Celsius?
Temperature.
Okay.
Plus.
What is 2 atmospheres? Okay. And what do you need to calculate?
The moles.
And moles is represented by
6.02.
N. So which is the formula you will use here?
P1. P, V.
Okay.
P por V entre T igual a P por
You need to use this formula because you cannot use P1 T1 or P2 T2 because we don't have an initial and final pressure or volume or temperature. So please calculate the result. Okay, temperature always in Kelvin, and the constant here will be 0.082, and remember that it has mixed units because it has liters, atmospheres per mole Kelvin. Okay, so this is how we calculate the result. We just isolate N, we replace the variables, and we do the calculations. Imagine that I ask you now, did someone copy this? Okay, thank you. Okay, so now, how many liters of water vapor will be produced
Miss, pero ahí.
yes.
Estamos cambiando otra equation, estamos haciendo otra.
It is another problem. How many liters of water vapor at these conditions will be produced by the 3 liters of hydrogen we have already
Antes.
calculated?
O sea, tenemos que usar otra equation, ¿no? Otra fórmula.
Sí, es otra fórmula.
I told you it was 25 Celsius and it was 2 atmospheres?
Eso era el programa pasado.
Yes. So, from those 3 liters of hydrogen that were measured at 2 atmospheres and 25 Celsius, how many liters of water vapor measured at 50 Celsius and 1,000 millimeters of mercury will you get? What will you do if I include a problem like this in the exam?
Use Avogadro's law.
Okay, well, now we already know how many moles are this.
Yes.
How many moles of hydrogens do we have here? Okay, I know that this equals 0.24 moles of hydrogen. Yes? Now what?
¿Hacer multiple choice ese tipo de problemas?
No, of course not. Huh? Okay, remember that we already had the reaction balance. It was like this.
Y haces que dos moléculas de hydrogen son dos moléculas de estudio.
So here, we already know that the proportion we have in the balance reaction is what we need to take into account. As Andres said, we know that 2 moles of hydrogen okay.
¿Pero qué fórmula usó ahí?
Okay. First, we know that we have 0.24 moles of hydrogen, and as the relationship is 1-to-1 because 2 moles of hydrogen produce 2 moles of water vapor, so 1 mole of hydrogen will produce 1 mole of water vapor, then 20.24 moles of hydrogen will produce 20.4 moles of water vapor. Now, how can I get these 20.24 moles of water vapor into liters?
Yes.
¿Qué hago ahora?
You have to find the oxygen. You have to find the moles of the oxygen.
No, we already know how many moles of water vapor we have
Mol es 22.4.
at STP.
Entonces, 24 moles.
We are not at STP. We have this temperature and this pressure. So we use the formula again, but now we have the number of moles and we need to calculate the liters at those conditions. Okay? So let me erase this. That's great, but it will not be included in the exam. So I use the same formula again. I will use PB equals nRT. Which are the data I have now? What is the new pressure now? What is the pressure?
No.
Yes. 1,000 millimeters of mercury.
¿Cuál es el volume?
What is the volume? This is what they are asking you to calculate. How many liters? Voy.
Y lo
Is the volume. So this will be my unknown. Ahorita lo calculamos. This is my unknown, okay?
Y luego es 0.
Then how many moles do I have?
0.0.
¿Perdón? No. Okay.
Es que si me dices qué fórmula usar, sí lo voy a hacer, pero yo voy a batallar.
This was what we used to calculate the moles of hydrogen. Yes?
Si no me dices qué fórmula usar, me voy a complicar mucho.
I will not tell you. Okay.
Bueno, multiplica 0.25.
So, Mariana. A ver. We already calculated how many moles of water vapor were produced from the 0.24 moles of hydrogen. And as the proportion is 2 to 2, we have the same amount. 0.24 moles of water vapor. Yes? But now, instead of having them at the same conditions as we had hydrogen, pressure and temperature have changed. What is the new volume of this amount of water vapor? If we had the same conditions, the volume will be 3 liters. But conditions have changed. So now we have this N equals 0.24. What's the new temperature?
50.
123 Kelvin.
50 plus 273.
123.
And which constant should we use now? As we have the pressure in millimeters of mercury, we can do 2 things. We can either transform the pressure into atmospheres or use the constant for millimeters of mercury.
Ahí está.
¿Mandé?
Es constant.
Como 10.
Y el si no estábamos todo me vas a hacer un.
Si saco todo mal, de que todas las 10 más de esas, ¿cuánto me va a dar?
4.80.
You will have like a 50. Why I am using this constant? Because now I have the pressure in millimeters of mercury. And I have a constant that has been calculated with millimeters of mercury. Ahí están los dos valores de la constante, Javier. So you can do 2 things. You can either transform 1,000 millimeters of mercury to atmospheres, that will be like 1.3, or you can use the other constant. It depends on the units of pressure you have, which constant will you use. Yes, but the first one uses atmospheres and the other one is millimeters of mercury.
Millimeters of mercury es 62.4 y atmosphere liters, o sea, es 0.
So now we need to isolate volume from this. Volume will be nRT divided by P. Yes? If I replace this, N equals 0.24 moles. Then I have the constant,
62.4.
and units here are mole, no, atmosphere liter, no es cierto, millimeters of mercury, liter over mole, Kelvin. Then we have the temperature is 323. And pressure,
Porque ahí te lo estaban preguntando en átomos, ¿no?
atmospheres, no atoms.
En atmospheres.
Okay, I cancel the units.
luego ya
mole with mole, Kelvin with Kelvin, millimeters of mercury with millimeters of mercury, and now I have liters. And the value, Andres, is?
4.84.
Huh?
4.84.
Okay, so this is the answer, 4.84 liters of water vapor.
¿y por qué desapareció el pressure?
¿Ah?
Ah, no.
No desapareció nada.
No, ya vi aquí, ya vi que lo pasaste.
Ahí estoy multiplicando todo. Okay. I don't know if I should ask, are there any questions? Yeah? ¿Perdón? Okay, let me stop the recording.